Right now, human-like robots are already working in factories. Not robotic arms bolted to the floor, but truly humanoid ones, with 2 legs, 2 arms, and a head. They walk around the shop floor, picking up parts, carrying boxes, sorting items, side by side with human workers. Just 5 years ago, you could only see this in movies about the future, and now it's a regular shift at a real factory. There aren't just 10 or 100 of them anymore. It's estimated that by 2026, more than 50,000 such robots will be commercially operating worldwide, compared to a fraction of that a year ago. And the most exciting part is yet to come. Their creators promise that very soon, such a robot will cost as much as an inexpensive car, and will come to work not only in a factory, but also in your home, cooking, cleaning, carrying bags. This is no longer the stuff of science fiction. It's happening before our very eyes. Here's how it works and what awaits us.
Tens of thousands of humanoid robots are already working on factory floors today. But why build a machine in human shape instead of using simple wheels and robotic arms?
Now look, why bother making a robot in human form? A logical question arises. Robots have been around for a long time. Robotic arms, those same mechanical arms that weld and paint cars, have been working in factories for decades, and they do a great job. So why build a complex bipedal robot that walks like a human? After all, making a machine walk on 2 legs is a hellishly complex engineering challenge. Wouldn't it be easier to build a robot on wheels or just another arm? And herein lies the brilliant answer that changes everything. Our entire world is built for people. Look around you. Doors, stairs, steps, handles, switches, tools, workbenches, machine cabins, all of it is designed for a creature with 2 legs, 2 arms, and hands and fingers. A typical robotic arm can do one task in one place. But if you want a robot that can work anywhere in this world, without redesigning everything around it, it must be human-shaped. Then it will fit into any environment created for us. It doesn't need special rails or a remodeled workshop. It will simply walk through the door, climb the stairs, and pick up the same tools a person can. Versatility, that's the whole idea. That was the engineering challenge, to make a machine that moves like a human. And that's incredibly difficult. Let's start with something simple, walking. A human walks constantly losing and catching their balance. Essentially, with every step, you fall slightly forward and put your foot out. Our brain and inner ear do this automatically, thousands of times a day without thinking. But a robot has to calculate it every split second. How to shift weight, where to place its foot, how not to fall on an uneven floor, on stairs, if it's pushed, plus hands. The human hand and fingers are a miracle of nature, capable of holding a hammer and not crushing a fragile egg. Replicating this subtlety in metal and motors is monstrously difficult. Now, let's talk about the heroes of this race. Several companies around the world have rushed to build humanoid robots, and it's become a real technological race. The most prominent player is Elon Musk's Tesla, with its robot Optimus. For now, it works mainly in Tesla's own factories, sorting parts and carrying loads. Musk promises that in mass production, such a robot will cost around $20,000 to $30,000, less than many cars. There's Figura, whose robots are already undergoing testing at a BMW plant. There's the famous Boston Dynamics with their electric robot Atlas, which can run, jump, and even do somersaults. And then there are Chinese companies that are already selling humanoid robots for less than anyone else, starting at $15,000. The race is on. On paper, it's fantastic. All that remains is to build it.
This isn't just lab experiments. A fierce global race between global tech giants and Chinese manufacturers is unfolding to make humanoids cheap and mass-produced.
And there's colossal money behind this race. The world's largest banks estimate that the market for humanoid robots will grow to tens of billions of dollars, and by the 2040s, hundreds of billions. Investors are pouring enormous sums into these companies because they believe that whoever is first to create a cheap and reliable robot worker will win one of the largest markets in history. And so, an interesting standoff has unfolded. On one side are Western companies like Tesla and Figura, betting on the most intelligent artificial intelligence. On the other are Chinese manufacturers, who are taking a different approach. They are already producing humanoid robots significantly cheaper than their competitors, and flooding the market with them. The West is currently ahead in brains, while China is ahead in price and production speed. In some ways, this is reminiscent of previous technology races. The winner is not only the one with the best technology, but also the one who can make it cheap and mass-produced. So the first question, how do you even get a robot to balance and walk without falling? See, here's the trick. The robot has internal balance sensors. Much like the vestibular system in our ears, they constantly sense which way the body is leaning, and the computer inside recalculates hundreds of times a second. If the body sways to the left, you need to move your foot or arm slightly to right yourself. The robot literally constantly catches itself, preventing itself from falling, just like you do, only consciously and deliberately. This is precisely why modern robots no longer fall over from a slight push. They are deliberately kicked during testing, and after a moment's hesitation, they regain their footing. What comes naturally to humans, the robot had to suffer through complex calculations. Just imagining what such a robot is made of is mind-boggling. The human body has hundreds of muscles and joints. To replicate at least some of this mobility, robots are equipped with dozens of motors, called actuators, each acting as a separate muscle in the shoulder, elbow, knee, or fingers. Advanced robots can have several dozen such controlled joints, and the hand alone has an entire system of tiny actuators to move each finger. All of this must be strong enough to lift heavy loads, precise enough not to crush an egg, and yet light and compact enough to fit within the human frame. Essentially, engineers are trying to squeeze the power of a forklift and the delicacy of a watchmaker into a human-sized robot. Each robot is a tightly packed tangle of motors, sensors, wires, and batteries.
Engineers squeeze the power of a forklift and the precision of a watchmaker into a single metal frame. But a physical body is useless without a mind.
But walking is just the body. Something else is far more important. What does a robot have instead of a brain? After all, it's not enough to just move. It needs to understand what's around it and what to do. And this is where the real breakthrough occurred, which is what's causing everything to happen right now. Previously, robots had to be programmed manually for every movement. Take a step here, turn your hand this way. It was time-consuming, tedious, and inflexible. But now robots are connected to artificial intelligence, the same one behind neural networks. Special models have emerged that operate on the principle of see, understand, act. The robot uses cameras to see what's in front of it, understands human speech, figures out what needs to be done, and then translates that into movement. And that's the whole point of this breakthrough. Now you can simply tell a robot, pick up the red box and put it on the shelf. And it will figure it out on its own. It will find the red box with its eyes, figure out how to pick it up, calculate the movement, and execute it. It no longer needs to be programmed for every little detail. It learns and figures things out on the fly, almost like a human being who has been given a task. It's precisely this combination of the human body plus the brain neural network that makes these robots truly useful. The body provides versatility, and artificial intelligence provides intelligence. Previously, it was the brain that was missing. Now, it's here. And how this brain is trained is a clever idea in its own right. A robot's neural network can't simply be programmed to perform any movement, as before. Instead, it is taught through example, almost like a child. One method is for a person to don special sensors or hold joysticks and show the robot how to perform a task, how to fold a shirt, how to pick up a cup. The robot records these movements and learns to repeat them. Another method is even more sophisticated. Thousands of virtual copies of the robot are trained in a computer simulation, a virtual world where you can experience years of training and millions of attempts overnight without breaking anything in reality. Then, the acquired skills are uploaded to the real robot. It turns out that one robot can learn from the experience of thousands of its virtual counterparts. And the more data, the smarter it is, just like neural networks that write texts and draw pictures. Incidentally, it's worth understanding why all this has exploded now, and not 10 years ago. Several factors simply came together. First, there was the breakthrough in artificial intelligence. Neural networks finally learned to understand the world and speech. Second, motors, batteries, and sensors have become significantly cheaper and better, largely thanks to the boom in electric cars and smartphones. from which these technologies have found their way into robots. Tesla, for example, directly uses the developments of its cars and autopilot in its robot. Third, there was a demand. In many countries, the population is aging and there's a labor shortage, and businesses are willing to pay for tireless workers. Each of these pieces had existed separately before, but now they have come together, and the humanoid robot has gone from a dream into a real product, one that the world's largest companies are competing for.
Breakthrough AI, cheaper sensors, and severe labor shortages aligned at once. But what can these robots actually accomplish right now, beyond impressive promotional videos?
Now let's be honest. What can these robots really do today without embellishment? At presentations, they dance, do somersaults, and pour drinks, and it looks impressive. But in real life, things are more modest. Today, their strengths are simple, repetitive tasks in a clear, predictable factory environment. Repositioning a part, sorting, moving it from one place to another. But in situations where fine fingerwork is required, or where things are unpredictable, they often make mistakes and drop objects. Their hands and arms are still far from human-like dexterity. And there's a common problem: battery. Many of these robots operate for only an hour and a half to several hours, before needing to be recharged. So, the ideal robot assistant is still a long way off. We're just beginning. And there's another huge issue engineers are thinking about: safety. A robotic arm behind a fence in a factory where people aren't allowed is one thing. A powerful, heavy robot that walks close to living people, and potentially even near your children at home, is quite another. Such a robot could, in theory, accidentally push someone, knock something heavy down, or knock them down with a simple misstep. That's why they're designed with care. They're covered in soft materials, limit their force, and are taught to freeze if a person suddenly appears nearby. The robot must be strong enough to carry heavy loads, but safe enough to avoid injuring anyone standing nearby. Finding this balance is a complex challenge in itself, and it's precisely because of this that robots are being put on hold. First, they need to ensure their safety. And here arises a big and troubling question that concerns everyone. If robots learn to do human work, what will happen to the people themselves, to jobs? After all, if a human robot stands like a machine, never gets tired, never gets sick, never asks for a salary, and works around the clock, why hire people for hard and monotonous labor? Some believe this is a catastrophe that will leave millions without work. Others counter that robots will take over the dirtiest, most dangerous, and most exhausting jobs. Jobs for which it is already increasingly difficult to find people. And the population of many countries is aging, creating a labor shortage. We will find out who is right in the coming years. But it is almost inevitable that the labor market will change significantly. Now, let's talk about the future, the very purpose of all this. The creator's ultimate dream is not just a robot in a factory, but a robot in your home. Imagine a humanoid assistant who loads the dishwasher, folds laundry, cooks food, brings things, and helps the elderly get up and move around. This is precisely what the companies are aiming for: to make a robot cheap and safe enough to fit into an ordinary apartment, just like a washing machine or refrigerator once did. Some companies are already testing home robots in real homes. And if this works, everyday life itself will change. Routine tasks will be taken over by a machine. Although there's a certain dread here, not everyone is ready to let a powerful robot, one that sees and hears everything, into their home. This creepy aspect deserves special mention because it's important. People have an innate wariness of anything that resembles a human but isn't. Psychologists call this the uncanny valley, a robot that's too human-like, with its not quite lifelike movements and vacant stare, triggers an unconscious anxiety. So creators are racking their brains over what kind of robot they need to be to make people trust them. Some make their faces deliberately simple, without any attempt to pretend they're alive, while others, on the contrary, add friendly facial expressions. After all, for a robot to work alongside us and live in our homes, it's not enough to make it smart and safe. People need to stop being afraid of it. And that's perhaps no less a challenge than teaching it to walk. Technology can be built, but people's trust must be earned. That's the whole point. For decades, human-like robots existed only in science fiction and labs, performing memorized tricks for cameras. But now, two things have converged. We've learned to create a body that moves dexterously enough like a human, and artificial intelligence has emerged, giving that body a brain. And as soon as these two things converged, robots have stepped out of demonstrations and into real workshops. They're being made human-like, not for aesthetics, but because our entire world is tailored for humans, and such a robot fits into it without modification. We're standing right at the point where a human-shaped machine ceases to be a curiosity and becomes an ordinary worker. And then, perhaps, an ordinary resident of our homes. And you know what's most interesting here? All of this is unfolding right now, in our lifetime, very quickly. Just 3 years ago, a humanoid robot was a scientific curiosity. Today, there are tens of thousands of them in factories, and tomorrow, engineers promise, they will cost as much as a car and enter homes. We are essentially living in the early years of an era when a new kind of worker is appearing alongside humans, an artificial one, in our very own eyes. And the main question now isn't, will it work? It already is. The main question is, how much this will change our world? And are we ready to live alongside machines that look just like us? But building a human-like robot is one thing. But what if we take on the elements? Catching the world's largest rocket from space, or keeping an entire city below sea level? That's the topic for next time. If you're interested in how humans are building the future right now, subscribe. Here we explore humanity's boldest breakthroughs. See you in the next episode.